All right, if you're prepping for your AWS Solutions Architect exam, you know performance is everything. Today, we are going to get right into a service that can literally make or break your application speed, Amazon ElastiCache. Let's get you ready for that exam.
So here's our game plan. First up, we'll dig into the why, the whole problem with latency. Then we'll meet ElastiCache itself, figure out how to choose the right caching engine, and then really get into the weeds of architecting solutions. We'll wrap it all up with some real-world use cases and those best practices that are absolutely critical for the exam.
You know, as an architect, you're constantly thinking about the user experience. And let's be honest, nothing makes users bounce faster than a slow application. Every single millisecond of delay can mean lost customers and lost money. So the real question is, where is all that slowness usually coming from?
And this quote right here, this gets to the absolute heart of the matter. This is the whole reason ElastiCache exists. You can spend weeks, even months, tuning your database or your APIs, but at the end of the day, reading from a disk or making a call across a network will always be orders of magnitude slower than just grabbing something straight from memory.
Yeah, just think of your database as the hardest working part of your whole setup. But what happens when it gets buried under a mountain of requests? Everything grinds to a halt. And that's exactly where a cache comes into play. It's like a shock absorber for your architecture, taking all that pressure off your database. So an in-memory cache is basically a super fast middleman. It sits right between your application and your database, and it holds onto the data that gets requested all the time, keeping it right there in RAM. What does this mean? It means for all those common requests, you get to skip that slow, expensive, and repetitive trip to the database completely. Okay, for the exam, you've got to nail this. When you're deciding what to cache, just ask yourself these three things. First, is the query slow and expensive to run? Second, is the data being hit over and over again? And third, is it okay if this data is a tiny bit out of date? If the answer is yes, yes, and yes, then boom, you've found a perfect candidate for caching. So, how does AWS help us solve this problem? Well, say hello to Amazon ElastiCache. This is a fully managed service, which is just a fancy way of saying you can forget about all the headaches of setting up servers, patching them, and figuring out how to scale them. AWS handles all of that for you.
Now, as the architect, one of the very first decisions you have to make is which engine to use. ElastiCache gives you two great open-source options, Valkey, which is a fork of Redis, and Memcached. They each have their own unique strengths, so let's put them head-to-head.
Listen up, because this is a classic exam scenario. Understanding the real differences between these two is absolutely non-negotiable. The choice you make here is going to have a huge impact on what your caching layer can actually do. The difference is pretty stark. If you need more than just a simple key value store, we're talking advanced data structures like lists, hashes, sorted sets, even JSON, then Valkey is going to be your go-to. It's packed with features. But if all you care about is raw, multi-threaded speed for simple bits of data, that's where Memcached really shines. So the key takeaway is this: Valkey for features and flexibility, Memcached for pure, unadulterated simplicity and speed.
Okay, so you've picked your engine. What's next? Well, now you've got to decide how you want to deploy and manage it. And this is another one of those key concepts you'll definitely see on the exam. And that question leads us to the two main ways you can deploy ElastiCache. Do you want to roll up your sleeves and design your own cluster, picking out instance types and managing capacity yourself? Or do you want to go serverless and just let AWS handle all of that heavy lifting for you? And trust me, this isn't just a technical question. It's a business decision. Seriously, think of serverless as the easy button for caching. You literally just create a cache, give it a name, connect your app, and you're done. This is all about getting to market fast. AWS takes care of all the scaling and management, which frees up your team to focus on building great features instead of managing infrastructure. Node-based clusters, on the other hand, are for the architects out there who need that precise, fine-grained control. This is for when you want to optimize for the long haul, tweaking costs and performance. You get to choose the instance family, the exact number of nodes, and tune every single parameter to perfectly match what your workload needs. And here's the core trade-off, laid out plain and simple. For the exam, you got to remember this. Serverless is perfect for simplicity and automatic scaling. Think new applications or workloads with unpredictable, spiky traffic. Node-based clusters give you maximum control, which is just what you want for established workloads where you can really dial in the performance and optimize every last penny. You know, building for failure is a core principle of being a good architect. With node-based Valkey clusters, you've got two incredibly powerful tools for resilience. Multi-AZ is your safety net, your disaster recovery plan. And read replicas, well, they're your secret weapon for scaling out those read-heavy applications.
So, let's play this out. What happens when your primary node fails? Well, ElastiCache immediately kicks in and starts promoting a replica to take its place. Now, there is a very brief window during this handoff where writes might fail, but the whole system is designed to recover in a flash.
Behind the scenes, ElastiCache is busy updating the DNS to point to the new primary node. And the best part? Your application, without you changing a single line of code, just reconnects and keeps on chugging. It's a completely seamless, automated process that's designed to keep your application online.
All right, enough theory. Now that we've got the fundamentals down, let's see how ElastiCache is actually used out there in the real world. We'll look at some of the most common use cases and then wrap up with some best practices to really lock in all that knowledge for your exam.
I mean, ElastiCache is just incredibly versatile. You've got the obvious one, database caching, but it's also perfect for things like managing super fast distributed user sessions or powering real-time analytics dashboards. It can even handle complex stuff like gaming leaderboards. And lately, it's become absolutely crucial for generative AI, handling things like semantic caching and vector search for those big language models.
Take a gaming leaderboard, for example. Trying to manage that in a traditional database can be a real headache. But with a data structure in Valkey and Redis called sorted sets, it becomes ridiculously easy and efficient. With one simple command, zid, you can pop in a player's score or update their existing one. The sorted set automatically does all the work of re-ranking everyone in real time. Then, pulling the top scores is just another single command. It is unbelievably efficient and just goes to show you the power of using the right tool for the job.
Okay, to wrap things up, here are the absolute key best practices you have to remember for the exam and just for building good systems in general. Always use cluster mode so you can scale out. Pool your connections because creating new ones is expensive. Send your read traffic to the replicas to take the load off your primary. And please, set smart timeouts in your client. Nailing these will help you build a truly robust caching layer.
And that really brings us to the final question you should always be asking yourself as an architect. Deciding between Memcached and Valkey, or choosing serverless versus node-based, or planning a high availability strategy. These aren't just little technical choices. They are fundamental architectural decisions that are going to define your application's performance, its resilience, and its ability to scale in the future.